Welcome. In this segment, we'll talk about how you can explore the image collection that is inside Google Earth Engine. Google Earth Engine is such a great platform, mainly because it has stored all of the image collections from the different public sources inside the Google Cloud server farm. And you are no longer needing to download images yourself. You can simply just type in code and use these images that are previously already stored on the Google servers to process them yourselves. And in this segment, we'll talk about how we can explore them. So let's get right to it. Before I begin the image collection, there is one feature that I want to mention very quickly. That is this bar on the top here, as you can see, that says search places and datasets. And this is the main place where you can search the variety of datasets that is inside of Google Earth Engine. So for example, if we wanted to look at, say, the Landsat image collection, and we wanted to look at Landsat 5, we can simply just type in Landsat 5. So pardon me for the all right, so yeah, I forgot to put the space, and that came out to not have any results. So if just that's a lesson for you. And once you have typed in the space and also the name of the image collection you want to use, you can simply have these different results of a variety of image collection that were associated with Landsat 5. The first time you are seeing this, you might be very confused why there are so many different collections to a satellite image that should just have one single collection. So USGS has already processed a variety of algorithms that based on Landsat 5 raw scenes. And these can be used for a variety of different purposes. So as you can see there, tier 1, as I am pointing my mouse there, that is the actual raw scene of the Landsat 5 image. So that is what you see directly out of a satellite camera. And tier 2 is also the raw scene. And this is a little bit more processed based on comparing to tier 1. And then going on, tier 1 and tier 2 TOA reflectance, those are associated with the top of atmospheric remediations, as you see here. And that's what the TOA means. And because the satellite image has a lot of distortions, especially when the image is taken from the satellite, the lights that come from the ground that reflects back to the satellite camera contains a lot of distortions. Obviously, there are a lot of atmospheric distortions or clouds or moistures that's in the air that will distort the light that travels from the ground up to the satellite. And TOA is a way to remediate that distortion to create a much more clear image that is reflecting what is on the ground. So if we look back into the results here, you will see these tier 1, tier 2 TOA reflectance. There are also other image collections. I will not go to every single one of them. If you want to know more about the details of these collections, you can simply just click on one of them. So for example, if I want to learn the Landsat 5 surface reflectance tier 1, I can just click this. And then it will open up a description of the image collection that I'm interested in. So here we have a lot of information that's packed into here in terms of details, the different scenes, informations that are readily available for you to read about and to know about. There is also the bands information. If I click this tab, it will show you the variety of bands that is stored inside this collection inside Landsat 5. As well as the image properties. If I click this, you will see a variety of various image properties. And this is another way to check out the metadata that is inside these image collections. One quick thing I wanted to point out is the collection snippet. So you can see there the EE image collection and then the ID of this image collection from Landsat 5. And what I'm highlighting here is the image collection ID, and that's the most important part that you will want to know to import into your script to further process your data. So this is the way you can look at the details of the image collection. And as I have pointed out earlier, the different data sets that are stored inside Google Earth Engine does not just include images. It also includes vector as well. So if we want to look at, say, a watershed, a global watershed vector layer, we can simply just type that in and it will show us the vector data layer that we can use. There are a lot of data that is being stored inside Google Earth Engine. And if you ever get confused about them or you don't know where to start, the search bar is your friend to get into that, know more about the data that is inside Google Earth Engine. So once you import, I will explain how you can process that image collection or vector that you are interested in. So if we go back to the script here, this is an example that I use to look at the Landsat 8 image collection. And as you can see, very familiar from what I talked about earlier on line 10 that I'm highlighting here. This is exactly what you've seen earlier about the snippets of the image collection, and that is associated with the unique ID of this Landsat 8 image collection. Let's begin from the top. So on line 5, that is where I construct a point, and this point helps me to locate myself in the world, and it's particularly located inside the city of Syracuse. And we can also use this point to filter the image collection to give me all the image of Landsat 8 that were captured to look at the city of Syracuse. And Landsat 8 is a large collection of images from the satellite. So there obviously are a lot of images stored in there. Another way to filter these images is to store by the dates that they were taken. So here I have constructed a start date and an end date. And By constructing the date, as I'm highlighting here on line 6, this is how you can input dates inside Google Earth Engine and store them as values to use later. So once I construct these two helpful filtering features, one is a point and the other two are the start and end date, we can use these inside this filter function on line 11 and 12 to help us filter more into the details of what we want to look at. So on line 11 is where I filter the entire Landsat collection to extract all the images that were taken at City of Syracuse, which is a point we constructed on line 5 there. On line 12 is where we can filter the image collection based on the time of when the image was taken. So here we are only interested in 2014, June to October. So this is how you can construct a date filter that is shown to you on line 12. And then finally, we print this filtered collection, and we can look into the metadata into what our filtered image collection looks like. On line 15 is where the image collection is filtered even further. So this line 15, I used the function I highlight there first, and that's basically a way to filter all of the image collection and just show you the very first image collection that's in the stack. And we can also look at the metadata, which we use the print function on line 16 that I will show you in a moment when I run the script. On line 19 is I am using another example of how to filter the image collection. And here we use another different image collection. As you see there, it has a different ID of image collection I'm highlighting there. And this one has the TOA in it, so it explains it's different from the other image collection I've used on line 18. And in this image collection, I wanted to filter based on the path and row numbers of an image. So the path and row of an image, as you see on line 20 and 21, those correspond to every single Landsat image that that was taken. And it's a grid system. You can look it up anywhere. And each image is associated with one of the grid, and that grid has a number that contains the path and the row number that's unique to that grid. It's basically like a coordinating system that the Landsat archive has been using to store images. So when we use this 15 and 30, we're basically storing image, we're basically filtering image based on that grid system. On line 22, that's where we can directly input the dates that we want from start to end to filter this image collection we just imported in. And here I wrote exactly the dates as I'm highlighting here. So this is another way, comparing from the example I had from before on line 12. This is how you can directly write into your dates that you want without constructing the date object values. Then we also print this, and just to look at it in the console for the metadata. And I will show you how that looks like in a second. There are other, of course, ways you can process a image collection. One of the very popular way of looking at the metadata of image collection is to look at how many images are stored inside that image collection. So here I used a function that is called toList, as I'm highlighting there on line 27, and also the length. So toList, there is basically numbering every single image that in that image stack by numbers, and to the maximum number of 100. And the length function is looking at this image stack, or looking at the number you have just generated to look at how many numbers inside of that collection. And we finally print this length value, which is named as size, as I'm highlighting there on line 27. And when we print it, we labeled it as number of images, which we'll see a second how many images is in that filtered collection. Another way of showing how many numbers of image is inside an image collection is on line 31, as where my cursor is pointing at. And that is simply using the size function, as I'm highlighting there. And that is another way, very similar to line 27, as showing you there how many number of images is inside an image collection. On line 35, that is where I explained before. So there are different metadata associated with an image collection. And inside every single image in that image collection, there are a variety of different data that associate with that image. So here, for example, if I want to look at the sun elevation, as I'm highlighting here, I can aggregate all of the metadata that is associated with every single image in that collection that I want to look at. And I can just extract the sun elevation of every single image and construct a list of all of those elevation data and print them out here in the console. And this is exactly what I'm doing on line 35 by using this aggregate status function that I'm highlighting here. And this basically look into the image collection, extract the metadata you want for every single image, and compile them into a list that can be printed out or used later. On line 36 is where I print out that collection of sun elevation inside this image collection. On 39 is another way, yet another way to filter an image collection. And here we can process that image collection by looking at how much cloud is inside the image. Oftentimes we want to work with image that has less cloud, and this is a way to simply do that. So here I use the combination of the sort function, which I am highlighting there, and also the first function I'm highlighting there. So the sort function explains basically we wanted to sort this image collection by how many clouds or how much cloud is for each image, and we want to put the least cloud covered image on the top and the most at the bottom. And using the first image or the first function I'm highlighting there, that gives us the most clear image that has the least amount of cloud. On line 40 is where we print this image into our console, and that will show us the metadata associated with that image itself. And lastly, we can look at the image collection by sorting the image collection and just look at, say, the top half or the top 10 in this case of the image collection. And we first sort the image collection by when the image was taken. So where I'm highlighting here, the sort function help us to sort everything by this metadata that's named system time start, and that's associated with when the image was taken. Then the next part comes as limit function, so that limits only to the top 10 images that we want to look at inside this image collection. And we put the 10, and that's very straightforward. And lastly, we print this image collection, and that is how you can look at the metadata associated with this collection that we just sorted. And we should be just finding 10 different images in this image collection. So if we run this script, we can just hit run there on the top. And you will see the console has a lot of different text popping up. So first is corresponding to the image collection. So this is the image collection that we have filtered that corresponds to line 13. And this is where we printed the amount of images that were taken at Syracuse at that point where we have placed inside Syracuse, and also match the criteria of these images were taken between 2014 June to October. And as we can see here, we are only seeing 11 different elements, and that just shows us there are 11 different images filtered out based on our criteria. The second output, as you see there, this is the corresponds to line 16. So just to reiterate, what I did on line 16 was to look at the first image that is in the stack of the image collection we have just filtered out. And this is a single image, as you see there, as where my mouse is pointing at. And this is different from the image collection on the top because an image collection obviously has a image already stored in them and a variety of different images there. So the next output is corresponding to the image collection, which was on line 24. And this is where we print the metadata of the image collection we filtered with the path and row metadata that I mentioned before. So here we can see if I expand this, you will see this is an image collection, and there are 15 different elements inside of this image collection. So that's also corresponds to there are 15 different images stored inside of this image collection. And then the next result we are seeing here are the two different numbers there. So you see the number of images, that's 15, and then the count of image, that is 15. So these are the two different values associated with line 28 and 32. And these are basically what we did before, as we wanted to look at how many image is inside that image collection. And this confirms that those two approach give us the same answer, which is there are 15 images inside that image collection we're looking at. And the next we printed out is the sun elevation statistics. And if I click this arrow here, as you see, there are a variety of different statistics inside this sun elevation statistics. And just to correct what I said earlier, so if we go back to the script, on line 35, this function that I highlight here is the aggregate statistics. This is just giving you the statistics of the sun elevations metadata that we are looking at. There's another function which constructs a list of all the sun elevations of every single image inside this image collection, which is another function, and that is not what I mentioned earlier. So this aggregate stats function gives us what we see in this console, and it gives us the maximum, minimum, and all the other variety of statistics. So this is very helpful if someone wanted to use the image collection and wanted to simply just look at the image collection metadata and want to make sure things are going okay and everything is consistent inside that image collection. And then the next result, as we see in the console here, is the least cloud image. So this corresponds to basically the what you see there is the least cloud image, and it was supposed to be just an image that we filtered that corresponds to line 39 and 40 of the code, and those are where we did sort the image collection by the coverage of cloud inside of the image collection and only extract the first image on the top of the stack. And moving on, lastly, the last result we print in the image console, or the console tab here, is the recent images. So in this example, it is corresponding to the line of 43 towards the end there, as you see, and the line 44, those basically where we want to just look at the 10 most recent images from the image collection we're looking at. So if we go back to the console there, we should be able to see there are only just 10 different images. In the area where I'm pointing my mouth towards there, the recent images has this image collection printed out already. And if we just click on that, and now you can be able to see there are 10 different image or 10 different elements inside this image collection that we can use further. And this confirms our filtering process went well there. So there you have it. This is how you can work with image collections and explore the different image collection that are stored inside Google Earth Engine. And in the next segment, we will talk about how to work with image projections. Hope to see you there.